Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a fascinating paper from May 5th, 2025, called Voila! Voice-Language Foundation Models for Real-Time Autonomous Interaction and Voice Roleplay. This paper introduces Voila!, a new family of large voice-language foundation models. Now, foundation models are these very large AI models, trained on a massive amount of data, designed to be adaptable for many different tasks. Voila aims to create AI agents that can chat with us, more naturally, in real time, and with emotion. It uses a new end-to-end architecture, meaning it processes voice input to spoken output in one seamless flow, allowing for full-duplex or two-way, low-latency conversations. And for those interested in exploring this further, it's great that the researchers have also released the code for Voila on GitHub. You'll find things like Python scripts for inference. That's the process where the AI uses its training to make new responses. An examples folder, a Gradio demo, which is a simple way to interact with the model, plus links to the actual model weights and datasets. So definitely a good resource. Okay, so to understand what makes Voila special, let's look at Figure 1. This figure shows how voice conversation systems have evolved. First, in Panel A, we see traditional systems. User speech goes through several steps. Automatic speech recognition, or ASR, to turn speech into text, then natural language understanding, or NLU, to figure out what that text means, then some management, followed by natural language generation, or NLG, to create a text reply, and finally text-to-speech, or TTS, to say it out loud. Panel B shows a simpler pipeline using large language models for the understanding and response generation parts, but still with separate ASR and TTS. Then, Panel C illustrates an end-to-end voice-language model, like Voila E2E, going more directly from user speech to a voice response. And finally, Panel D shows an autonomous system, like Voila Autonomous, which can listen and speak simultaneously, making the conversation much more fluid. This is what Voila is really aiming for. Okay, Figure 2 delves deeper, showing the architecture, the internal design of the Voila models we just discussed. In Panel A, for Voila E2E, user speech goes into a streaming autoencoder, which is a system that efficiently processes audio as it arrives. This processed audio, along with persona details and a voice sample, feeds the main voice-language LLM backbone. For output, an audio transformer, a neural network for sound, and a voice tokenizer, which turns AI concepts into speech sounds, generate the voice response. Then, Panel B shows Voila Autonomous. The big difference here is it has two streaming autoencoders, one for your voice and one for its own. This setup is what lets it listen and speak simultaneously for truly natural interaction, as we saw was the goal in Figure 1. Both models also allow for easy voice customization using text instructions and audio samples. Alright, so we saw in the previous figure how Voila's architecture includes components like the LLM tokenizer and the Voila tokenizer, which, remember, help break down text and audio into smaller, manageable pieces. Figure 3 here really zooms in on how these pieces, called tokens, are used in a smart way. It shows Voila's, quote, text and audio interleaved alignment. Imagine the phrase, hello Voila. The text is broken into text tokens, and the speech sound for hello Voila is broken into audio tokens. Voila then lines them up meticulously, a text token, then its matching audio token, then the next text token, then its audio token, and so on. This tight one-to-one pairing is crucial for generating speech that's really synchronized and expressive. Alright, so we've talked about how Voila carefully lines up text and audio tokens. Figure 4 now shows us more about the input embedding. That's how these combined tokens are turned into a numerical format the AI understands, and the output decoding, which is how the AI generates its spoken response. So those interleaved input tokens get converted into, quote, mean embeddings. These embeddings are like rich numerical summaries. These then feed into the voice language LLM backbone. For generating speech, this backbone produces hidden features, which are internal, learned representations that guide the audio transformer. This audio transformer then creates layers of precise audio tokens, which ultimately form the voice output. The figure also shows a residual quantizer, which works with the audio tokenizer to break down sound into these detailed, layered audio tokens, capturing different aspects of the sound for the transformer to learn from. So building on our understanding of input processing from the last figure, figure 5 here really highlights the two-stream input structure. This is specific to Voila Autonomous and crucial for its ability to listen and speak at the same time. We see a user stream for your voice and an AI stream for Voila's own audio. Both streams get broken down into audio tokens, shown as A, and text tokens, T. These are then used to calculate the mean of embeddings we discussed, which then feed into the voice language LLM backbone. This parallel processing of both streams is what enables that really natural simultaneous conversation. Okay, so we've seen how Voila Autonomous handles inputs for conversation with its two-stream structure. Now, to really test how well Voila understands and responds across different topics, the researchers developed something called the Voila benchmark. Figure 6 here gives us a visual breakdown of what this benchmark covers. It's a bubble chart, where the size of each bubble represents a different subject area or domain included in this comprehensive test. We can see broad categories like math, human eval, which tests coding ability, and MMLU, which stands for Massive Multitask Language Understanding, and covers a huge range of academic subjects, all broken down into many smaller specific topics. This benchmark helps measure Voila's capabilities across a wide intellectual landscape. With that comprehensive Voila benchmark, we can really see the effort to ensure Voila is not just a good talker, but a versatile one. The key takeaway here is how Voila as a voice language foundation model achieves truly autonomous, real-time interaction, understanding and responding almost like a human. This research is a big step towards AI companions that can genuinely converse and engage with us. Thanks for tuning in to the AI Research Roundup. I'm Alex.